Alright, so we'll continue with question 2. Here we're trying to evaluate the limits that involves the infinity. So first one, the limit as x approaches infinity is what we're trying to look at. And then you have x squared minus 1 over x squared plus 1. So the basic idea that you need to know, and that I believe you've already learned under our discussion, you know that the limit as x approaches infinity, whether infinity or negative infinity, if it's 1 over x or any power of n, this you should know that it's equal to a 0. Why? You can actually try to observe this as you try to increase. If you're going to start from, let's say, 10, try 100, try 1,000, try a million. So you see that as you begin to increase the numbers below there, what do you begin to see? You begin to see that the value is going to be getting closer and closer to 0. So that's what it means. And this is actually true if you try to sketch a graph of any function in that form of 1 over x. Alright, so when you're given a fraction like this one, what you basically do is you need to divide by the highest power. Okay, highest power on both the denominator and the numerator. So this implies that on our next step, we're going to have the same limit as x approaches infinity. So if you check the numerator, what's the highest power? It is x squared. So divide by x squared. So we have x squared divided by x squared minus 1 over x squared. For the denominator, the highest power is also x squared. So divide the entire denominator by x squared. So after we've done that, on our next stage, you say that you're going to remain with x as x approaches infinity. The limit as x approaches infinity. Divide that, you have a 1. Then the other part, you also have a 1, but plus 1 over x squared. So at this point, you are now able to distribute the limit. Okay? So you remain with 1 minus. So where we have the x, that's where we're going to distribute the limit. So 1 over x squared, and then over 1 plus the limit as x approaches 0 for 1 over x squared. So I told you to say, if you're going to have 1 over x and then you've got x approaching infinity, not 0, you understand that they're all going to be equal to 0. So you're going to have 1 minus 0 plus over 1 plus 0. So at the end of it all, you're going to have 1 divided by 1, which just gives us a 1. So the basic idea is the limit as x approaches infinity or negative infinity in the form of 1 over x or x to any power, the answer is a 0. Okay, so that concept is very important and it will help you. It will help you in simplifying. So let's try to see what we can do for the other three. Feel free to pause the video and apply the same concept to the next question. So here we have the limit as x approaches infinity, and then we have 4x squared minus x minus 2 over 5x squared plus 4x plus 1. So for your own information, for people in a case where you have run out of time, just know that whenever you're trying to determine the limit of polynomials being divided, it's just get the coefficients of the highest powers. So coefficient on top is 4, on the bottom it's 5. So that would be your answer at the end of it all. Okay? So you understand that what you're going to do is you divide by the highest power, right? So the limit as x approaches infinity, don't forget our answer, our predicted answer is 4 over 5. So for the top part, you divide by x squared throughout. So you're going to have 4x squared divided by x squared minus x divided by x squared minus 2 divided by x squared. We're dividing by the x attached to the first one. And then for the bottom, 5x squared. So the highest is x squared, so divide by x squared throughout. X squared, x squared. So you remain with the limit as x approaches infinity. So that will cancel. So you remain with a 4 minus 1 over x minus 2 over x squared. There we have a 5 plus 4 over x squared plus 1 over x squared. So you understand that there's this point. This is a point we are going to distribute this now. So every part that is having x as a denominator is going to be a 0. And so at the end of it, we are going to have 4 over 5. I told you how to distribute in the previous example, so you can show that. So equally for the third one, you do the same. Here we have the limit as x approaches, this is t, as t approaches negative infinity. And then you have t squared plus 2 over t to the power 3 plus t squared minus 2. So for this one, we'll do the same. The limit as t approaches negative infinity, we divide by the highest power on top, it's t squared itself. So it will be t squared plus 2. So divide by t squared divided by. So for the bottom, we divide by the highest power, which is t to the power 3. So t to the power 3, t to the power 3, t to the power 3. So what we have? So I'll just go. The limit as t approaches negative infinity. So on top, divide. So you have 1 plus 2 over t squared. Denominator you have that will divide. So you have 1 plus 1 over t. And then that's a minus 2 over t to the power 3. So all the parts that are having a denominator of a t will become zeros. So eventually you just remain with a 1. This is very important. Now we have an interesting one, that's the fourth one, which is dealing with a radical. The limit as x approaches infinity, x plus 2 root of 9x squared plus 1. So apply the same concept of dividing by the highest power, including under the denominator or under the square root. So you're going to have the limit as x approaches infinity. So you have on top divided by x, you have x over x plus 2 over x. Denominator you're going to have the square root. Now we divide by x squared, 1 over x squared. So we have the limit as x approaches infinity. So this is going to be a 1. So 1 plus 2 over x, and then square root of 9 plus 1 over x squared. So you can distribute now the limit. So every part where we have x as a denominator, it will be 0. So we have 1 on top remaining, on the bottom we have root of 9 remaining, which will eventually be 1 over 3 as a result. Simple and straightforward, right?